The purpose of this video is to solve one-step inequalities. In solving one-step inequalities, there's a few properties that we need to go over. They're very similar to the properties of equality, but they're called the properties of inequality. The first property we're going to discuss is the addition property of inequality. If we're given an inequality like b is less than a, we can see on the number line that b is smaller than a because it's to the left of a. If we add a value c to both sides, so b plus c moves over to here, and a plus c moves over and moves the same distance, we can see that by adding, the inequality statement stays true. There's another property of inequality, and that is the subtraction property of inequality. The subtraction property of inequality says if we have an inequality of a plus b, a is less than b, and we subtract c, then they both move back the same distance, negative c, and the inequality statement stays true. The multiplication property of inequality has two different properties to it. The first one is if we have negative 2 is less than 3, and we graph those two values, negative 2 and 3. In this case, we're going to go ahead and multiply by 2 on both sides. When we multiply by 2, it makes this inequality even more extreme. Negative 4 is less than 6, which is a more extreme, or they're further apart. But if we have an inequality like 3 is greater than 1, and we plot those 2 points on the number line, and we multiply by negative 2, not only does it increase the distance between the two values, but it also moves it to the other side. So if we take 1 times negative 2, it gives us negative 2. And if we take 3 times negative 2, it makes that distance more extreme, but on the other side of the number line. Therefore, these end up flipping. Negative 6 is less than negative 2, so that symbol, the inequality symbol, will need to change from a greater than to a less than symbol. Therefore, anytime that we multiply or divide by a negative, it flips the symbol. There's a lot of other ways to explain this, but this one is a diagram. It's quite easy to follow, and we can see how it changes it because it moves it to the other side of the number line. We're going to do a few examples together. In this first example, number 15, we need to go ahead and solve for g. To solve for g, we got to get rid of that 22. To get rid of 22, since it's a positive 22 on both sides, we're going to go ahead and subtract positive 22. We're going to subtract 22. When we subtract 22, we're using the subtraction property of inequality. We get g is greater than negative 7. We're going to go ahead and graph our solution here in the directions it asks us to graph. So we draw a number line, put 3 numbers on it, negative 8, negative 7, and negative 6. It's not included, so we've just put an open circle and we shade all the values bigger or greater. In our interval notation, we're going to go ahead and start with the smallest number, which is negative 7. We do not include it. That means we put a parenthesis and we go off to infinity. In our next example, number 16, the first thing we want to do is combine these two symbols. We have a minus and a negative. When we have a minus and negative, it changes it to y plus 3 is less than or equal to 9. This was a simple simplifying step. We just simplified the one side. And now we want to go ahead and subtract 3 from both sides. This is using the subtraction property of inequality. Now we get y is less than or equal to 6. We go ahead and graph our number line, and for our purposes we just need to put 3 numbers on the number line, 5, 6, and 7, and then we go ahead and put a circle on 6 and we fill it in because it does include it, and we shade all the values smaller than 6. In this case, our smallest number goes on backwards forever, or to the smallest number of negative infinity. So we go from negative infinity all the way up until 6, and since 6 is included in interval notation, that means we put a square bracket. Let's go on to our next example. We'll go to number 17. In number 17, in order to get w by itself, we need to divide by 5. Dividing by a positive value does not affect this inequality symbol. So we just get W is less than negative 6. This was the division property of inequality. In this case, we're going to go ahead and graph our solution. We draw our number line. We put our three numbers on it, negative 7, negative 6, and negative 5. We put an open circle on negative 6, and we shade all the values smaller. In interval notation, we've gone from negative infinity all the way up to negative 6, and a parenthesis around both of them. In our last example, in order to solve this, we're going to multiply by negative 6 on both sides. Since we're multiplying by a negative, we're going to go ahead and flip the symbol. So then we get P is greater than or equal to positive 24. Remember, we only flip the symbol if we multiply or divide by a negative value. In this case, we're going to draw our number line. We're going to have three numbers, 23, 24, and 25. We put a circle on 24 as that's our boundary point right there. Fill it in, and we're going to shade all the values greater than 24. In our interval notation, the smallest value is 24, and then we go off to infinity. We put a parenthesis around infinity and a square bracket around 24 since it's included. This is how we solve one-step inequalities.